In this lab, you are to determine the relationship between position and time for an object undergoing constant acceleration. Okay, in this cart, when it goes down the hill, will undergo constant acceleration. So now we want to collect data. We want to see how long it takes to go from 0 to 0.20 meters, and then from 0 to 0.40 meters, and then from 0 to 0.60 meters, all the way down to 0 to 1.60 meters. And I'm going to use these photo gates to do that. So let's do the first run. Okay, the two photo gates are 20 centimeters apart. And I'm going to move this cart right up to the first photo gate, but so that it doesn't cross the light beam, but it's very, very close. So when I click collect and release the cart, the time I get will be how long it takes the cart to go 0.20 centimeters from rest. And that turns out to be 0.9904 seconds. Okay, now I'm going to move the gate an additional 20 centimeters down the ramp and repeat. Okay, I'll release the cart from rest, and I get 1.696498 for 40 centimeters. And now I'll move the second gate, the stop gate that is, down an additional 20 centimeters. Release the cart at the 0 meter position. And I get 2.1753 seconds. Okay, move the stop gate down an additional 20 centimeters. (2.4529 seconds). Okay, an additional 20. And we get 2.8388 seconds. And an additional 20. (2.9208 seconds). And let's see if that's all we need. 1, 2, 3, 4, 5. See, we have 1, 2, 3, 4, 5, 6 times. So we need move down another 20 centimeters. Okay, here we go. And that's 3.4196 seconds. And last but not least, 1.6 meter displacement. Move the gate an additional 20 centimeters. Here we go. And we get 3.6 0.6612 seconds for a displacement of 1.6 meters. Okay, now what I'm going to do is I'm going to take this data and I'm going to construct a graph using the computer.
Okay, so we're plotting position versus time. The horizontal axis is time, and the vertical axis is position. Going to enter the data, so we have 0, 0, and then we have our time at 0.20 meters, our next time at 0.40 meters, our next time at 0.6 meters, and so on, all the way down to 1.60 meters. Okay, now I'm going to scale it, and I'm going to go to graph options and take off connect the points, but put on point protectors. And we're going to do a curve fit it with a quadratic. Okay, and that gives the shape of a parabola. It's a parabolic curve. And if we zoom in here, we can see what the coefficient A is. So we have position is equal to 0.09687 multiplied by the time squared. Okay, so now we're going to plot position versus time squared. So what I have to do is square the times, and I do that by making a new calculated column. Choose the variable time, square it, and now I click on the horizontal axis and choose calculated column, and you notice the data points straighten out. I do a linear fit, and if we zoom in on here, we can see that the slope of this line is 0.1182. The equation is position is equal to 0.1182 multiplied by the time squared.